Hello again, and welcome back to this series of short talks with Andreas on how to use 1M2M standards to build open and interoperable IoT systems. Let's see what Andreas plans to cover with us in this fifth talk.
Hello Ken. In our last talk, I showed you how to represent the elements of an IT system using a resource tree in 1M2M. In a practical deployment, the resource tree can become quite large and contain multiple levels of detail. Just think about how files are stored on your personal computer, only that there would be many more files. For today's talk, I will show you how to discover and get information about elements in the resource tree. Before I do that, let me make an analogy with the files and directories that are stored in the file system on your computer. How do you discover and retrieve information about each item?
So I guess you'd use a set of operating system functions.
Yes, that's right. You can think of a 1M2M common service functions in the context of an operating system for IoT. Resources are stored in the resource tree, and you can use 1M2M request to manage the resource tree and access any data structure or data that your IoT devices produce. Let's talk about how that works. Here is the example I plan to work with. In the real world, our notebook AE represents a small application running on a sensor device that provides periodic readings. I hope you remember from our last talk how this arrangement is represented in the digital twin world on the right-hand side of the picture. There you see the resource tree and containers to manage sensor data. In this case, we have collected 5 readings that are stored under the container, as you can see from the 5 content instance resource elements. Now I'm going to show you how we can search for specific resource instances in the resource tree using an adjustable filter to control our search. To make an analogy with a computer filing system, this is similar to retrieving all files with a certain name or only spreadsheet files. So let me switch to the Jupyter binary window and take you through these steps. There are 2 things I want to cover. First, I will show you how to retrieve all the content instances from a container. We should expect to see 5 items. Next, I will show how we can create a content instance with a label that can store some user-defined meta information. This will modify the resource tree. When I try to discover it, we should expect to see only 1 item.
Okay.
So, as usual, let's start with initialize this notebook. As you can see, we have the whole structure already being prepared for us. There's this application entity, the container, and 5 content instance resources underneath it. Let's jump to the next request. Here you can see just a normal retrieve request that targets the container resource. It has a couple of new attributes. First, it's a filter usage attribute that says it's a conditional retrieve that basically says, okay, now apply a filter for this request. The next attribute shows you this filter. It's a filter criteria, and we are looking only for content instance resources. For the result content, we have configured it to return the references to these resources, not the resources themselves. If I click on it and execute it, then you see the normal request and the response. And you can see in the response body a list of all our resources under our container.
So you told us we would get 5 results, which you are showing here. If I go back to the file system analogy, it looks like these are descriptions of 5 items that would appear in our file system.
Yes, that is correct. It is like a directory overview about what could you expect if you would retrieve those resources individually.
Okay, so how do we go about looking at the content of these resources?
Oh, that is not a problem. Let me show you. We scroll up to our request, and then we change the result content attribute and removing the references here. that is something that you can play around when you are working with the notebooks yourself. So now the result content is expected to have the child resources instead of the references. Let me execute this. The request is executed. And now what you can see here are the whole resources instead of the references.
Okay, that's quite a lot of detail. And I can imagine it becomes unmanageable if you have a lot of readings from your sensor. How can we be selective about what information we're retrieving?
Yes, let me show you. We can, for example, go to the next request. And here we are adding now a content instance resource with a label. A content instance is a resource that holds your data, but now we are going to add some meta information in form of a label. The label attribute can contain any kind of meta information that you want to pass along and store along with your data. For example, here we are just saying, okay, we're adding a tag that is called greeting. Let me execute this. And scrolling down, and you can now see that our request contains the labels with the tag that we are provided here. Scrolling a bit further down, you can see that we are now a new content instance here in our resource tree. If we want to discover this specific content instance that we attached some extra meta information on it, we are jumping to our next request. This request is again a filter request. The filter criteria this time contains the label with our tag and the greeting that we applied before. If we execute this one now, we can see that we will only receive in the response this specific resource with the label attached.
Okay, and can we use different kinds of tags? So if we want to get the oldest or the newest reading, is that also something that would use the filter criteria?
Yes, you can filter by size, under a specific size, above a specific size, under a specific creation time, for example, or something like that.
Okay, so there's quite a lot of flexibility built into the filtering mechanism. Okay, Andres, thanks for that. We can lead people to play with the notebook and try different filters themselves. For our next talk, what do you have lined up for us?
So far, we have dealt with building up the structure, introducing the application containers to build data models and to store the data using content instances. The next one will be about groups. If you have to deal with more than one device, if you want to apply your actions, your request to several devices in one go, that is what groups are for.
Okay, until we meet again then.